On April 23, 2026, a magnitude 4.0 earthquake struck southeast Missouri, specifically at 12:59 p.m. local time. With an epicenter situated 51 miles east-northeast of Jonesboro, it caused the ground to shake back and forth for several seconds. Thankfully, the brief ground motion did not cause any damage, with peak motion being equivalent to what is being shown in this simulation. What had just occurred was the strongest earthquake to strike within any part of Missouri since 1991, with the quake occurring at a depth of 7.3 miles or 11.8 kilometers. Now, you might think it to be a bit strange for an earthquake to have struck the state, as it did surprise many locals. However, it really shouldn't have been too much of a surprise, as the very spot it struck is shared as the highest risk category in this U.S. Geological Survey Seismic Hazard chart, with it being the same color that encompasses the entire San Andreas Fault and the west coast of the lower 48 north of Cape Mendocino stretching up to Cape Flattery. Yet, those two areas are located on or in close proximity to major and active plate boundaries, while Missouri is not. But there's a catch. You see, the quake which occurred in Missouri on April 23rd was related to an ancient attempt and eventual failure at forming a plate boundary which left large fault lines in the crust. Specifically, a continental rift which once attempted to break North America into, known as the Reelfoot Rift. The Reelfoot Rift began forming about 530 million years ago when the region was located south of the equator. After tens of millions of years of rifting, a rift valley approximately 40 miles wide and 200 miles long had been created. The Reelfoot Rift eventually completely ceased its spreading for good around 490 million years ago. This left behind a series of lengthy normal, reverse, and strike-slip fault lines largely oriented perpendicular to the original spreading motion of the rift. These faults in the more than 450 million years since have been buried by 5 to 6 miles thick of sediment, yet still represent a large long-term zone of weakness in the crust. Thus, since the broader region is undergoing a form of compression, strain builds up on the most likely spot in the region to accommodate this strain, the Reelfoot Rift. This notably resulted in 4 major and destructive earthquakes between 1811 and 1812, but such major earthquakes are uncommon, occurring within the Reelfoot Rift about once every 500 years on average. Magnitude 6 and magnitude 5 range earthquakes are still quite rare but do occur here, but most common are quakes in the magnitude 4 or less range. This is why for the vast majority of years since 1970, the Reelfoot Rift had been the most seismically active region in the United States east of the Rocky Mountains. The quake which struck on the 23rd was almost purely strike-slip in nature and occurred on a right lateral strike-slip fault line oriented to the northeast. While not a perfect match, there is still a decent chance that the April 23rd quake occurred on one of the larger faults in the overall rift known as the axial fault. Currently, the odds of any larger magnitude aftershocks in the near future are quite low per the U.S. Geological Survey, with this magnitude 4.0 quake merely representing one of the approximately 200 average earthquakes the new Madrid Seismic Zone, which the Reelfoot Rift is a part of, produces every year. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.